All right, in section 3.6, we're going to look at rational equations and how to solve rational equations. So a rational equation is simply going to be an equation that contains a rational expression. So we talked about complex fractions. So it's just an equation that's going to have some of those little rational fractional expressions that we've seen before. Now some can be really, really easy, and some can be more difficult. For example, I could have a really easy one, like x divided by 2 equals 2 over 4. Those have really easy rational expressions. I could have more complicated ones that have lots of binomials, x plus 2 over 2 minus 3x over x minus 1 equals 7. But for all these, again, it's an equation, so we're just trying to find what value of x makes the equation true. So there are lots of methods to solve rational equations. We're going to go with probably the easiest tried and true method. And we're simply going to solve rational equations by multiplying each term by the LCD. So just like in complex fractions, when I multiplied everything by the LCD, it made a lot of the denominators disappear. Same thing will happen here. When I multiply everything by the LCD, the bottoms will all cancel out, and I'll be left with some function on the top that I can solve with factoring or quadratic formula or a linear equation or anything like that. So the one problem with a rational equation when you solve them is you'll sometimes get what is called an extraneous solution. Now, extraneous solution is essentially going to be a solution to the equation that does not check. And the way this happens in a rational equation is something that makes the denominator 0. We've talked lots of times how the denominator cannot be 0. So if you have a solution that makes the denominator 0, it can't be a solution. So if I were doing, say, this problem, 2 over x minus 1 minus 3 equals 4 over x plus 2. So let's say I did all the work and I found my answer was 1. Well, I know 1 cannot be a solution because if I plug 1 in the denominator here, I get 2 over 0, which is undefined. You cannot make denominator 0 ever, so that is why that would not have a solution. We'd say it is an extraneous solution. If you eliminate all the possible solutions, then these can be no solution. So let's look at a really easy one to start, and then we'll look at some ones that are a little trickier. So this says solve the following rational equation. So what I'll do is we said we're going to multiply everything by the LCD. So I should probably figure out what the LCD is. Now if I look at the denominators here, I see x minus 3 and 2x plus 3. They really are not this, they're not the same, they really have nothing in common. So our LCD is simply going to be both of those. X minus 3, 2x plus 3. So now what I'm going to do is I'm going to multiply this to both of the terms, all of the terms, which there are only 2 in this case, and see what happens. So my original equation, 5x minus 3 equals 12 over 2x plus 3. So I'm going to multiply that LCD, and we always multiply it on the top of both. If there were 3 terms, I'd multiply it to all 3. If there were 4 terms, I'd multiply it to all 4. If something didn't have a denominator, I'd still multiply it to that. We just multiply it to all those. So now we see that the 2x plus 3's will cancel, the x minus 3's will cancel in each one. So what I'm left with now is 5 times 2x plus 3 equals 12 over x minus 3. And so now this is just an equation I can solve like I always have. I'll distribute the 5, so that'll give me 10x plus 15 equals 12x minus 36. I'll get all the x's on one side, so I can take away 10x to both sides, and I can add 36 to both sides just to get the x's on one side, because there's no exponents, it's just linear. So I get 2x on this side, I get 51 on this side, so x is going to be 51 halves. We should check that it's not extraneous because it doesn't make either of these denominators 0. So this would be our solution. Okay, let's look at this next one. So it says 5 over x minus 3x plus 6 equals 7/2. Now, one thing I like to do, and I did it on the first problem but didn't really mention it, I always like to put things that are binomials in parentheses. I think that will help out a lot. So, and you'll see why. So my LCD in this case, I have x, I have 2x, and I have 2. So the expression that contains all those is simply 2x. So what I'm going to do is I'm going to take my equation, which is 5 over x minus parenthesis 3 plus 6 over 2x equals 7 over 2. I'm going to multiply all those by 2x. So 2x here, 2x here, and 2x here. And again, what you'll see, lots of things cancel. So we have the x cancels here. So we have 2 times 5, which is 10. The 2x cancels here, and this is why it's really important to put those parentheses, because we have the negative sign, and then we have the 3x plus 6. So our next step will obviously be to distribute that negative sign. If you don't have those parentheses, that's something really easy to miss. Here the 2's cancel out, and I'm left with 7x. So when I distribute that negative sign, minus 3x minus 6 equals 7x. I can put the 10 and the minus 6 together. We have 4 minus 3x equals 7x. I can add 3x to both sides. Again, I'm just getting the x by itself. So we have 4 equals 10x. Divided by 10, x is 4/10, which of course reduces to 2/5. We should check if that's extraneous, but the denominators here are x. Well, 2/5 is not going to make that 0. 2/5, no, and 2, obviously not. So this one's fine. But always just check in those denominators to make sure you don't have an extraneous solution. So this next one here, we have a little more complicated denominator. We have a 3x minus 1, an x, and a 3x minus 1. So our LCD, well, we obviously have to have 3x minus 1 in our expression that's going to contain everything. But we also have this little x. So my LCD is going to be x, 3x minus 1. So when I write my equation out, my original, and again, I'm going to put parentheses around everything that's a binomial, which in this case is just the 3x minus 1s. So when I add my LCD, I can cancel out the appropriate things. So this is times x, 3x minus 1. This is times x, 3x minus 1. This is times x, 3x minus 1. So lots of good stuff cancels. Something cancels in every one. So what we're left with now, though, is a quadratic. We have 3x times x, which is 3x squared, plus 3x minus 1, because we just have this 1 that we're distributing, which really doesn't change it, equals to just x, because we never canceled that x out. Well, because it's a quadratic, now we have to get everything on one side. So I'll subtract x from both sides. 3x squared plus 2x minus 1 equals 0. So now we have a quadratic. You can solve this any way you want. Factoring, quadratic formula, whatever. I'm going to factor it because this does factor. It's 3x minus 1, x plus 1. And I'll leave it to you to check that to make sure it does factor like that. But again, if you don't like that, use quadratic formula. So we have 3x minus 1 equals 0 and x plus 1 equals 0 as our two solutions we're solving for. So this will give me a solution of negative 1 when I subtract 1. Here I'll add 1, and then I'll divide by 3, so I get x equal 1/3. So here are my two solutions, potentially. Because one of these solutions actually does not work. And the one that does not work is the 1/3. Because if I look up here in my denominators, 3 times 1/3 is 1, and 1 minus 1 is 0. So it makes a denominator 0. So right away, because it makes one of the denominators in the original 0, I have to eliminate it as a solution. It is what's called extraneous. Now, if I put in negative 1 is not going to be a problem in any of the denominators, so my only solution is the x minus 1. There will be cases where both solutions don't work. You can have ones where they both work, anything is really possible with that. Okay, let's look at this one. So we have 2x over x minus 4, 10 minus 5x over x squared minus 16 equals x over x plus 4. So lots of things to put in parentheses here. Lots of binomials. We got this one, we got this one, we got this one, we got this one. But the interesting thing about this one is if you look at this denominator x squared minus 16, we know that's the difference of squares. And you should always factor all your denominators because it just makes finding the LCD much easier. Because otherwise, if you think that as an independent one, you have a huge LCD. But now, if I look at all the terms that are in any of the denominators, it's simply x minus 4 and x plus 4. This LCD contains all the factors from the denominator. And that'll make the problem much easier, obviously. So we have 2x, x minus 4, plus 10 minus 5x over x minus 4x plus 4. And we have x over x plus 4. So I'm going to multiply x minus 4x plus 4 to all these terms. And then again, lots of good stuff will cancel. We'll be left with something and we'll solve it from there. So we'll cancel this. This will cancel both of these. And here we'll just cancel the x plus 4. So let's see what we have left. We have 2x, x plus 4, plus 10 minus 5x. And I'm just going to remove the parentheses because there's nothing in front. Equals x, x minus 4. So we have quite a mess here. So we'll distribute. We get 2x squared plus 8x plus 10 minus 5x equals x squared minus 4x. And again, that's just distributing that and distributing that. Now on the left side, I can see that I have these two x terms, so I can just add those together. So I have 2x squared plus 3x plus 10 equals x squared minus 4x. And now again, I have a quadratic, so I'm going to move everything to one side. So I'll subtract the x squared from both sides, and I'll add the 4x, because in a quadratic, you want to get everything on the same side. So we get x squared plus 7x plus 10 equals 0. Again, quadratic formula of this, factor it, whatever you want to do. So I will factor it, x and x, 5 and 2. So my two solutions will be negative 5 and negative 2 potentially. And if I look at all the denominators in the original, negative 5 and negative 2, well, the only things that would make the bottom 0 would be 4 or negative 4. So these are both fine. So my solution is simply negative 5 and negative 2. So the key thing is getting that LCD to eliminate all those denominators. Now, same thing on this one. We have some things to factor when we're getting our LCD. Put these in parentheses. Now, this second one will factor as 3z minus 2 when I take a z out. I can just take a GCF of a z out. This guy also factors, and not surprisingly, it factors as 3z minus 2 and z plus 3. So those 3z's minus 2's match up. Now again, I'll leave it to you to take a second and see how that factors. Make sure you get the same factorization as I did. So LCD is simply going to be the 3z minus 2 and the z plus 3. We have to have those because we have them there. We have to have a regular z for this guy here. But the nice thing, the third denominator is z and 3z minus 2. I already have all those in my LCD, so I don't need to add anything. So I'm going to multiply that to the equation. So I have 3z over 3z minus 2, z plus 3, that's the first one, minus 1 over z equals 4 over z 3z minus 2. And now I'll multiply all these things to all those denominators. So we'll have z, 3z minus 2, z plus 3. We'll have z. We'll have 3z minus 2. And we'll have z plus 3. All times just -1. And then we'll have z, 3z minus 2, and z plus 3. So hopefully lots of things cross out, which they do. So this is what we're left with. So let's see if we can't decipher what's left. So we have actually quite a mess. So the first one is actually the easiest one because we just have 3z and z, so we have 3z squared. Then we have minus 3z minus 2, z plus 3. So we have to FOIL it and then distribute a negative sign. And on the other side, we have 4 times z plus 3. Well, the nice thing is I know how this first one FOILs because it's just basically my first denominator. You're certainly welcome to FOIL it out, but I will promise you it turns out to be this. I can distribute the 4 on this side, so 4z plus 12. But we have this little negative sign in front of the parentheses, so we have to distribute that. So we end up with 3z squared, and it's actually a really good thing because I get 3z squared minus 3z squared minus 7z plus 6 equals 4z plus 12. So like I said, the 3z squareds go away. So we're left with minus 7z plus 6 equals 4z plus 12. And again, it's linear, no squares left, so I'll just get all the z's on one side. So I'll subtract 4z. So we get negative 11z. I'll also subtract 6 to get that to the other side just to save time. Equals 6. So I get negative 11z equals 6. So z equals negative 6 over 11. Let's look at one more. Same idea here. So if I put these all in parentheses, every binomial, and I'm going to keep doing that. I think that's a good thing. I know this guy factors as x plus 4, x plus 2. That will help me get my LCD of x plus 4, x plus 2. So now I'm going to multiply that to all the terms. 2x, x plus 4, plus 7x plus 12 over x plus 4, x plus 2 equals x plus 1 over x plus 2. So we'll just add all those, the LCD to all those. So x plus 4, x plus 2, x plus 4, x plus 2. I know I shouldn't write it like that, but I'm out of room. And I know they're going to cancel. So I'll multiply that to all the numerators. And then just start canceling. Those cancel, both of these cancel, and just the x plus 2 cancels. So I end up with 2x, x plus 2, plus 7x plus 12, equals x plus 1, x plus 4. So now I'll just simplify everything, get everything. If it's quadratic, get it on one side. If it's linear, just solve it. I'm pretty sure it'll be quadratic because when I distribute, I get 2x squared plus 4x plus 7x plus 12. Over here, I'll have to FOIL. So x squared plus 5x plus 4. And again, I'll assume that you can FOIL that out on your own. So that leaves me 2x squared plus 11x plus 12 equals x squared plus 5x plus 4. So it's going to be a quadratic, so I'll try to get everything on one side. So I'll subtract the x squared, I'll subtract the 5x, and I'll subtract the 4. So I get x squared plus 6x plus 8 equals 0. Solve that. Factors is x plus 4, x plus 2. But now the solutions are negative 4 and negative 2 based on those two factors. But if you remember the original, negative 4 would make this guy 0, and negative 2 would make this guy 0. So those both don't work. So these are both extraneous solutions. So after all that work, the solution is simply no solution. So a lot of algebra in these problems, but nothing terribly tough. Please let me know if you have questions on rational equations.